Okay, so just as a super quick review of yesterday, we did a really quick review of the Pythagoras theorem. Really important we have that down. The types of questions you're going to be experiencing is assuming that you're able to recognize when to do this and to do it correctly. And so just a quick summary of that. When do you need to use Pythagoras? When you have 2 of 3 sides of a triangle and you're trying to find that third. That's when you know that, oh, I need to use this. This is the thing in my toolkit I need to use. As to how to use it correctly, if you're not too great with the algebra part of it, and that's okay, a lot of students are in that boat, where you're not able to manipulate this equation, what you can do is you can just memorize these 3 things here, and that will get you there. This is why I handed that out yesterday. It's that sheet here. If you're trying to find the C, you would use the one that has C by itself. If you're trying to find A, you use the one that has A by itself. Trying to find B, use the one that has B by itself, essentially. As long as you know that C is your hypotenuse, which is always opposite of your right angle, you'll be okay. So again, just to summarize, the 2 things you need to know is how to use it and when to use it. Those are the 2 primary skills that you need for this upcoming unit. It's potentially I would say, probably the hardest unit of the class. At least that's what some students have told me. Yes.
Okay, yesterday I asked you for help.
Yes.
And I still want to finish that question.
No. Okay. I can't help you right now, but yeah, I wasn't able to, but we will definitely check in today to work on that. Okay, so that's Pythagoras. So what we're working on for this unit here, I've dedicated a little bit of extra time for this just to make sure we have enough time to fully go through it. So this is the properties of geometric shapes. Fancy way of saying we're going to be dealing with triangles. It's called a quadrilateral, 4-sided shape, and then it's called polygons, like 6-sided shapes. We're dealing with shapes, and we're essentially using logic. There's some rules in place to try and find sides or angles. That's what we're trying to do. We're trying to find sides and angles of different shapes. The Pythagoras theorem is the one that really everything kind of boils back down to. That's going to be your bread and butter for this first part of it for sure, for this 5.1. Just as a really quick refresher, I'm just going to go straight to page 176. And I'm just going to do one of these. I'm just going to do one of them. I'm just going to do question 1. Again, first thing you want to do is you want to I'll make this bigger so everyone's able to see. First thing I want to do is I want to label my sides. I can see in this case my unknown side is my hypotenuse, and I'm just going to say sure, this one's going to be A, this one's going to be B. Doesn't matter which one you do. So I've labeled it. Perfect. Next, I just want to put my correct formula in, if you remember. In this case, I'm finding C. So I'm going to go to my formula sheet. This is the one with C by itself. So I'm going to use C squared is equal to A squared plus B squared. So I put my formula in. So check, I've done that.
So why it's A squared plus C squared equals C squared?
Oh, it's A squared plus B squared. A plus B squared. So I do A squared plus B squared. So next is I have my formula. The next step here is just substitute the stuff in, right? I now know what my A, B, and C are. I know my C is unknown, so I'm going to leave that unknown. My A is 69.3, so I'm going to put that in there. It's 69.3 squared. Not a very good mouse, so. And I know my B is 47.6. I know it's very small, so I apologize. So 2 final steps. I'm going to square it, and then I'm going to take the square root is what's going to happen there. So if I square it, all I'm going to do is I'm going to take my calculator. Was it 69.3 squared plus 47.6 squared. Add that up, I get 7,068.25. So C squared is equal to
So would it be 84.07 or 34.5?
Ooh, let's go take a look at that.
Resolution going up on this one.
6, 8. Oh, I like where you're going with that, and I'm actually gonna bring that up in just a second here. I like that you observed that. So I've squared it, and I'm gonna take the square root of it. So I'm gonna take the square root of both these things. So the 7,068, take the square root of that. 84 point. Now, to your point, Kim, you said you're wondering, like, is it 84? Is it 84.1? Is it 84.07? Normally what we like to do is we like to do 2 decimal places. What this chapter specifically is going to assume is it's going to assume you're going to default to whatever place you see. So in this question, I can see it goes to 1 decimal place. It would assume you go to 1 decimal place. You can always be more precise. You're not ever going to lose marks for that, but there's going to be some instances where you might get 7.99. It's going to be easier just to round it to 8 in that case. So you can use your best judgment here. If you go more precise, you're not ever going to like lose marks for that. It says 1 decimal place, so I'm just going to use 1 decimal place. So it's going to be 84. I'll just do 84.1 centimeters. So again, that's just a quick summary of Pythagoras. It's a skill we need when we move forward here. So I'll leave it up there for just 1 second, and we're going to head on. Okay. So I'm just scrolling down here. Now, this next page here, this is a review, if you remember, of trigonometry, of like SOHCAHTOA. We're not doing that. We're skipping it. Skipping it. Skipping it entirely. It's only used a little bit in this unit. We will be revisiting it probably in about 2 weeks' time. But for this specific unit, we're just not going to bother with it. Okay, we're just not going to. There'll be a couple questions we're going to have to skip because it's asking for angles that you need to use this for. If you remember how to do it, great. It's not the key thing of this unit. It takes a lot of time to get SOHCAHTOA, to get trigonometry. We're blowing past it. Skip. And that's all of this stuff here. All this stuff here is trigonometry. If you want to do it, great. I'm not going to force you to. We're just going to go straight past it into our new stuff here. Cool. So the first thing we're really working out with, the first shape we're really going to start looking the properties of is triangles. We know how to find the sides of a triangle. We have previously learned how to find angles. We'll revisit it later. We're not doing that now. But so what do I mean by actual properties? Well, a property of a triangle is, for example, it has 3 sides. Right here, and you're going to want to actually like highlight these, box it, something. This is literally a property. It has 3 sides. I took an entire university class, a whole university math class, just about prove a triangle is a triangle. That was the class. Prove a triangle is a triangle. Some of it is you have to prove it has 3 sides. It's a closed figure. What that means is that, closed figure. This is an example. This is not an example of a closed figure, right? This has 3 sides, but there's a little gap there, right? This is not a closed figure. Closed figure would be completely sealed. And then this is the big one. All of those angles inside of a triangle add up to 180 degrees. You take any triangle ever, you try to measure it, it will always add up to 180 degrees inside. All 3 of those angles will add up to 180 degrees. So those are the properties is what they're called, the characteristics of it. So something I really, really want you to pay attention to, this is something I find students really struggle a lot with, is we're going to eventually be classifying triangles by angle measure. So I'm going to recommend you make sure you really make a note of this angle thing here.
Like comment.
Sorry?
Comment.
Yeah, circle it, just make note of it, put a star beside it, something, box it, whatever it is. But it's sometimes going to ask you, classify it by angle, classify it by side. And so it's not hard concepts, but the thing that we usually forget is we just forget which one's which. That's always seems to be the biggest problem I see. So you might have seen these terms before. There's acute, which means all those angles in the triangle are less than 90 degrees. We know what a 90-degree angle is, right? 90 degree is just goes straight up. There's a right triangle, we've worked with those quite a bit now. And there is something called an obtuse triangle. That's where one of these angles is really, really big. It's bigger than that 90 degrees. So acute, smaller than 90, right angle is just 90, and then obtuse is bigger than 90. Those are the three types of triangle by angle. So I want you to stay on this page. I want you to stay on that, what is that, 179? I just want you to tell me. I'm going to give you 5 seconds. Don't yell it out. I'm going to be asking people randomly.
You sucks.
What?
You suck.
No?
What did you say?
You sucks.
It's not what we're yelling. So what you're going to be doing is I'll be asking people randomly.
Like, really? Make it happen? Then you sure or something.
Well, it's not really the math. So what I have here is an example of a triangle. Just want you to tell me in 3 seconds, is it acute, right, or obtuse?
Are you playing it or?
Oh, I didn't point at anyone there. So yeah. So no, well, I'll point at Kim in this case. It's a right triangle, yeah? Had 90-degree angle. Aiden? Acute, right? Every angle there is less than 90. Jasmine? This one is obtuse. Yes, because you're right. It doesn't have any like markings, but we can tell just by looking at it, right? Like this thing right here. If this was a right triangle, it just goes straight up. It goes past that a little bit. Austin, going to be asking you here. Do you think this is, we're on page 179. Do you think this is acute, right, or obtuse? Sorry? This one is actually going to be an acute angle one. All these angles are less than 90 degrees. Stephen, what's your guess for this last one? Stephen?
I'm gonna say it's gonna be. Left.
It's not a type of triangle. Make sure you just follow along, right? We're on page 179. So this is a tricky one. What?
Is that up to you?
This one is, that's the less than symbol. So all those angles are less than 90. It's a mean one. It's acute, yeah. Well, so we don't actually know what these angles are. We just know they're all less than 90. Oop. I'm going to come back to those same 5 images later. So when I say by angle measure, look at the angles. Look at the angles. Look at the degrees they have. Because if you flip to your next page, you're going to see 3 more classifications. You're going to see classifications by side length. So there's a difference. There's angles and there's sides.
What page?
Now we're on page 180. Yeah. And again, you may have seen these words before, you might not have. We have something called an equilateral triangle. This is where all 3 sides and all 3 angles are the exact same measure. Now, this is what most students I find with this new unit is they tend to struggle with the most is there's some memorization that has to happen here. Like when you look at an equilateral triangle, if I ask you what this angle, if I told you this angle here was like 60 degrees, you would have to know that, oh, this one's 60, well, this one's 60. And you see how they have the same markings, right? So I'll zoom in just a tad on this one, equilateral. That's what these little symbols mean. You might have picked up on that already from our previous interactions with them, but all these have one line here. All these angles have one line. That means those are the exact same angle. They're the exact same angle. If one's 60, the other one's 60. If I do something like this, though, let me do black. If I do this, there's now 2 lines here. That means these bottom 2 angles, those are the same, but that top one's different now. So these little lines have meaning behind it. Same thing when I go to these ones on the sides. All of these sides have one line. Those means all those sides are the exact same length. If I told you the bottom's 5 centimeters, the left side has to be 5 centimeters. The right side has to be 5 centimeters. So equilateral triangle, all sides and angles of that triangle are the same. Next, we have something called an isosceles triangle. Isosceles right here. So this is where 2 of your sides have that same length. You can see in this triangle, 2 of them have that little dash. That means those are the same length. which also means two of those angles have that same measure. You can look on the bottom left and right corner of that. They're the exact same. And then finally, we have a scalene triangle. Scalene triangle is just something where there's no commonalities. Everything's different. Every angle's different. Every side's different. And you can see, if you look really closely on this bottom triangle, right triangles fit that. A right triangle is technically a scalene triangle. So where this is eventually going to go is you're going to be asked to classify, to label triangles by side length and by angle. So basically, if I was to show you a triangle, for example, this one, we already know, if we flip it back to 179, we know this is a right triangle, right? This is a right triangle. You say, oh, this is a right triangle. It's also a, what other type of triangle based on 180? Scaling, yeah. So this is a right scaling triangle is what you'd say. It's a right scaling triangle. If it asks you what's the classification, oh, it's a right scaling triangle. That's what you would say for that. So I'm gonna pick on you here, Kim. What would you label this triangle as now, based on 180, page 180? Equilateral, right? Because the angles are the same, the sides are the same. Yep. Aiden, next one.
Up to scaling triangle.
It is up to scaling, absolutely, right? A lot of people get thrown off by all these markings, right? This just means there's no markings that are the exact same. There's only one side that has one line through it. That means there's only one side that has that length. All these ones being different lengths. There's only one angle with one bar. There's one angle with 2 bars. There's one angle with 3 bars. Everything's different. Every side and angle on that one's different. So up to scaling, absolutely. Jasmine? Sorry? So it's isosceles. Yeah, you're right. And so what's the angles with it? Acute, yeah. So it's an acute isosceles triangle. Perfect. And Austin, last one. I'm giving you a really hard one here. So first off, if you're looking at 179, what angle is that one? It's an acute angle, and then what side? That's the next page on 180. So it's an acute something triangle. What's the something? It is an acute, so in this case, probably scaling. We actually don't know for sure. It doesn't actually give us enough information to know. So scaling is a good guess there. Absolutely. So you could say, yeah, it looks like it's an acute scaling triangle. That's a pretty reasonable assumption. Okay, so those are the different classifications of triangles. That's all we're really focused on. That and Pythagoras, that with those tools now, with those 3 tools, angle classification, side classification, Pythagoras, that's what we can use now for the rest of the lesson. So for example, here's an example question you might get asked. What is the length of side BC? We might not have read this before. If you're looking at the side BC, that means take B, draw a line to C. That's what that is, right? Side BC wants to know the length of this red line here. Let me just do that. This is kind of a blast from the past from last block here. But so how could we find this? Well, here's what I know. What do I know about this triangle? I know these 2 sides here are the exact same. These 2 sides up here are the exact same. Oh, it's an isosceles triangle. What do we know about
B squared and then
We'll end up there. So it's an isosceles triangle. So I know that two sides equal length means two angles are the same. Look how these two angles are the same, how these sides are. Okay, I know these two angles are the same right here as well. I can use that because I know it's isosceles triangle. So because these two sides are the same, because these two angles are the same, there's a pretty good assumption that this line going through in between them is the middle.
It says it's 24 centimeters long.
Don't go to the next page. So in this case, if I'm trying to find what the length of BC is, if I know then that this is an isosceles triangle, this middle line cuts it in half, it's the same triangles on both sides of it. If I figure out the length of this line here, this really thick line I'm drawing, I can just double it, and all of a sudden I have the length of the line I'm trying to find at BC. Okay. And so now I have two sides. I'm now trying to find. I'm going to just focus on this triangle here. I'm drawing in blue. So blue. Yep.
I'm bright blue.
What?
I'm bright blue.
I need you to collect yourself a little bit here, Stephen.
It's all good. I'm bright blue to the world, yeah.
I need us focusing on the math stuff here, okay? So, all right, so so what we need to do is we need to find the length of this BC. If I find the length of this bottom line here, that is X with it, I can figure out the length of the whole thing. So I have 16 and 20, right? Yeah. So I can take this triangle. I'm just redrawing the same triangle I have. All I've done is I've redrawn the blue one. I know the height of it's 16. I know the hypotenuse is 20. I have two sides trying to find a third side. Pythagoras. So all I need to now do is I need to label my triangle, right? I know this is 20 is my hypotenuse, so that's my C. It doesn't matter what my A and B are then. I'm just going to classify it like that. I'm trying to find my B. I know I'm trying to find B in this case, because that's what I put as the missing side. Okay, I'm trying to find B. If I look at my formula sheet, if I'm trying to find B, use the formula that has B by itself. B squared is equal to C squared minus A squared. So B squared is equal to C squared minus A squared. You can do some shortcuts here. Instead of writing, oh, I know C is 20, instead of writing 20 squared minus 16 squared, you can just skip it. Well, let's not skip it right there. Just for the example. Yeah. That will be the answer. But so C squared, 20 squared is 400. I'm just gonna go straight to that. A squared 60 is 16 squared. 16 squared is 256. Gonna write that straight in. 400 minus 256 gives me 144. All I need to do now is I just need to take the square root of it. So square root of 144 is just 12. So yeah, you're right, Kim. So I now know that my X here, this length down here is just 12. So it's 24, right? We've already established that X there, that 12 is half of the length. So I'm just going to double that. Times 2 gives me 24. Cool. Again, that's like some stuff we've seen before. Introduce some new stuff here. What I find that most students really struggle with, though, is question D in this case. And just because it's confusing wording. So all I'm going to do is I'm just going to draw a little, I kind of used up a lot of space, right? There was not a lot of space given to us. I'm just going to do a little box off here. Just so I know that that's question A. And with my remaining space, I'm going to do question B. So question B is classify. So how we read this thing here, this line right here, this thing I'm boxing, it's triangle ABC. So it's taken 3 points. It's taken point A, point B, and point C, and it's turned that into a triangle. Because there's a couple triangles in here, right? There's 3 triangles within that. There is triangle, let me use blue here. There's triangle ABD, right? That's this thing here. There's triangle ADC, that's that right one. And then there's this triangle ABC. So it's important to label which triangle you're working with. It can get super confusing otherwise. So I want to use the whole big triangle here, angle A, B, and C. Whole big one. I'm going to circle in blue. So classify it by angle measure and side length. So what that means is that's exactly what we just did with the PowerPoint. So if I'm looking at this big triangle here, what type of a triangle is that? First off, go with the angle. Go with the angle measure. That's the stuff on page 179. What type of triangle is that blue one?
Hot. Hot. You got like 3 of them right there. What the fuck are you talking about?
Yeah, this.
But the 2 triangles in there, so wouldn't that be like for 2?
Oh, so you're looking at the 2 triangles here. It is an acute triangle, but you're right. There's a couple triangles in there. That's why it labeled. It wants to know triangle ABC. So that's why they labeled them. Yeah. So that's why I drew that blue outline. But you're right. It is an acute triangle. So classify this by angle measure. It's an acute triangle. It's also a what triangle? That's on page 180 now. So I've done the angle measure. Now I want to do the side length. Isosceles, yes. So it's an acute isosceles triangle, and that's it. Boom, you're done. Angle, side, triangle.
So all I just say that?
Yeah, that's it. Yeah. Like for some people, this clicks really naturally. For some other people, it struggles a lot. And if you're one of those people who look at this, you're like, I don't really know what to do. It's sorry, it can be difficult. It can be really difficult for some people. It's really natural. Some people really struggle with it. And it's okay if you're in either one of those boats. If you are on the side that struggles with it, it's really important to come back to these 2 pages, look at the definitions and the rules with each triangle. There is unfortunately some memorization components with this now. That's just the 30 level class. We have to memorize some stuff. So if I jump ahead here, first off, there's the whole solution here. There's the whole solution here if you really want to go into it. I just want to jump straight ahead to page, what is it, 182? So 182, I just want you to, I'm going to give you 1 minute, just a single minute. It's okay if you don't get it. Just give question 4A a shot. But I'm going to give you a hint. Look at the lines here, right? Look at these 2 lines, understand what type of triangle that is and what that means. So 1 minute, question 4A. All right, 10 more seconds. Okay, question 4A. What do we know about this triangle? What type of triangle is it? It's isosceles, right? I know it's an isosceles triangle because it has those two lines here.
There's, less than 90 degrees, so.
And it's also an acute triangle. Perfect. Cool. So isosceles, it's an acute triangle. So all of our properties now can be found in those two classifications. Going to acute, all those angles are less than 90 degrees. Doesn't help us in this case. But if I go to isosceles, it tells me two angles of this equal measure. Two sides are the same, two angles are the same. Knowing that, I'm trying to find angle M in this case. I can use the fact that it's an isosceles triangle to figure that out. So thinking about this, how many, what's all the angles in a triangle measure up to? Not 90, 180, boom.
But.
Yep. So all the angles measure up to 180 degrees. I'm going to take away what I know.
Would it be 60 degrees? Because if N and P are 60. It's well, 50.
Possibly, let's find out. So first off, I'm going to take away what I know. I'm going to take away. Do you see this little symbol here? This means angle N. This little symbol here that you can see, angle N. Angle N I know is 60 degrees. I'm going to take away angle P. Now, angle P here, that's just what I'm drawing this little bar over, this little circle over. It's an isosceles triangle. So whatever angle N is, that means angle P has to be that same one. So that I know that one's also 60 degrees then. And if I do that, I should just get my answer. And you're absolutely correct, Kim. In this case, it's 60.
You are, you're lying.
Stephen, I need you to follow along in your booklet here.
Lying on me. Yeah. How bad it could happen.
If it's the same, then you have also be confusing.
Sorry?
Like, you be confusing.
So I have bad ears.
Would N to P, would that be 15 as well?
M to P, that length is 15. M to N is 15.
Yeah, but
And-
they have the same degree.
And they have the same degrees, they have the same side. And so you're looking at like this line. That one also would be that, yeah. Because all the angles are the same, all the sides have to be the same. Yeah. So next thing is
All threes would be threes.
all three of them would be 15 meters.
But how do you classify it? I don't, this,
So, and that's the thing most students struggle with. How do you classify it? What's the angle measure? So we've already done this. What's the angle measure? Not quite. Go back to 170, page 179. Which type of triangle is that? It's acute. And then what's the side triangle? Acute isosceles triangle. And that's it. That's your answer.
but
Yeah. Mhm.
It would be equilateral. I just didn't do this last time.
Actually, yeah, you're right. Fair point. It is technically an acute equilateral. Oh gosh, I've spelled that entirely wrong. Equilateral triangle. Good catch, Kim. Now you could get more specific here, like you could say, hey, MP is 15 meters, MN is 15 meters, NP is 15 meters. You could say that, but this is good enough. This, if you just say it's an acute equilateral, we can draw all that other stuff up from that. That's how you classify it, yeah. And that's what most students struggle with is they get a lot more complicated than they need to. Just what's the angles, what's the sides? It's that type of a triangle. Okay. Um. I want you to give questions 5 and 6 here, an attempt. I will be walking around the room in like 2 minutes, seeing how we're doing. So try question 5, try question 6 here with what you know. Ask for help if you need it, of course, but really go back to those two, page 179, 180, try and really understand what each of those types of things mean. So try question 5, try question 6. Oh, let me pause that recording. Recording. All right, so a little bit more than 2 minutes there. So question 5 here. Tell me in English, don't tell me math. How do you solve this? I'm trying to find length of PR. Sorry? Pythagoras, okay. I know I need to use Pythagoras because I'm finding a side, I'm finding one length of a triangle, and I know 2 lengths of the triangle. That's exactly it, right? I know this PR side's my hypotenuse, so it's really just going to be c squared is equal to 8 squared plus 8 squared. 8 squared is 64, so 64 plus 64 gives you 128. And you take the square root of that, and you got 11.3, yeah. 11.3 meters. That's exactly it. Now, when you classify this, what type of a triangle is that?
Right, isosceles triangle.
Yeah, right isosceles. And then question C, so it wants you to label, classify QRS. And like I said, there's a couple triangles in here.
That's still the same.
It's still the exact same, right? So now once you do this one here, that one is still going to be a right isosceles triangle. Okay. Question 6 involves an area question, a blast from our past, if you remember this formula here. So here's what we know. So this is a harder level problem right here, because we have to deduce some information from it. Harder level. If you know, if you did really well in this stuff in the last math class, you're probably going to do pretty okay in this one too. It builds on those previous skills. So here's what we know. I want to try and find the area of this triangle. My area to find triangle is base times height, right? I know what my base is. It already tells me. What I need to try and find is I need to try and find my height here. How can I find that?
A squared plus b squared and b squared, but, and then we would do the A or B and we subtract that from C.
Okay, yeah. So you're thinking Pythagoras. Now to use Pythagoras, I need 2 of the 3 sides. I know one of them. I know that one of the sides is 30. Let's just do like this. Let's use this. What's this length of WZ? 15, right? It's half of that 30. Cool. So all it's going to be then is, this is my hypotenuse. Sure, let's make you A. Let's make you B. So A squared is going to be equal to C squared minus B squared. 30 squared minus 15 squared. Oops, that's a 15 there. 30 squared is 900. 15 squared is 225.
Yeah.
Yes. You're gonna get 675 here, and you gotta take the square root of that, right?
So those are like whole numbers, I Just round it to.
That would be fine, yeah, yeah. If it doesn't specify, you can either go 2 decimal places, you can do whatever you want, really. As long as it makes sense, of course, how you got that answer.
Is that 15 squared?
675? oh yeah, sorry, this is 15 squared, yes, because it's half of 30, yeah. So square root of 6, what'd you get us for the answer there, Kim? 26? Sure. So 26 centimeters. Cool, now, but remember though, you're not done.
I know. 30 times 26.
Yes, so it's divided by 2 as well, yeah. So 26. So yeah, base times height divided by 2. My base is of this triangle is 30. My height's 26, as I've just figured out. So base 30 times by 26, divided all by 2, you're gonna get your area. What's my area of this thing?
So, and then divide by 2, so.
Yeah, so 390 centimeters squared. Yeah. Cool. All right, good work. Okay. So what you're gonna get some time to do here is, I want you to do the trial question 4. If you get stuck, it's an example. You can literally find the solution from the next page. Try not to use it. I want you to try question 6. So I want you to try example 4, and I want you to try question 7. They're very difficult questions. I want you to give those 2 a shot. Pause recording. All right, so just want to do a super quick review here. I won't go super in deep, but for example 4 here, as you guys, I think everyone's gone through that one now. What you've realized is you have 2 different triangles here. If you find the base of both of them, of this first triangle, ACD, using Pythagoras, you got like, what was it, like 16 point something?
16.97.
Yeah, you got 16.97. And then you did the same thing for the second 97, did the same thing for the second triangle. So 18 squared, take away 6 squared, you got what, like,
Oh, oops, I switched those around.
Ooh.
I got 12.64.
okay, 12.64. That's fine. And then 16.97, I think.
Yeah.
Yeah, so if you just add both of these up, all of a sudden you now figured out the full length of that. Perfect. Now for question B, again, that's what most people tend to struggle with. They overcomplicate it. You want to figure out the angle measure and the side length. So first off, it's triangle. I'm going to erase everything up here. It's triangle ABC. So just literally like draw an outline. A, B, C. It's this triangle. It's this left one here. What's the angle measure? Oh, well, it's a right triangle. Angle measure is it's a right triangle. I know that. What's the side length? It's a scaling triangle. The triangle ABC is a right scaling triangle. That's all you have to do. I know in this solution it asks for more complicated stuff, but you can draw everything else out just from that information. It wants to know triangle ACD. That's that right triangle there. Same thing. ACD is also right scaling triangle. And then triangle ABD, that's the whole thing. Yeah, so ABD, it's an obtuse scaling triangle. Now, question 7, I'm skipping on past a little bit here. Question 7, first off, you don't have to do question B with that if you don't want to. It uses trig. If you can, cool. I think it has a solution. Oh, it doesn't have a solution later. This is a tricky one. Question 7 is a tricky one. I stared at this, honest to God, for like 5 or something minutes. Like, I'm like, it can't be done. It's not possible. I didn't see that the height of it was 8. I ignored that. So again, it's really, really easy to miss out on important information. Sometimes you really have to look super closely. Because it can just be one small detail that turns it from an unsolvable problem to a solvable. So now what I need to do is I want to figure out how long the bridge is. And as you guys can see, you see how these bottom ruts have those two lines there? How many triangles have this?
Six.
1, 2, 3. Yeah, 6 of them. So how can I, so in English, the bridge is 6 of these long. 6 of these, this is not 11, this is this triangle mark there.
I rounded it to 8, like for
I'm gonna get to that. I'm gonna get to that one actually. So how did you get 8? How did you get 8 first time?
Well, I did Pythagoras with, because it's 8 tall and 11 point 3.
Yeah, so I've just taken that triangle I've outlined in red there. It's 8 tall. There's 11.3 as its hypotenuse.
And then a right triangle.
A, B. Yeah, so this one, so B squared is going to be equal to C squared minus A squared. So if you do that, you should end up with, I don't know what, I'm just going to put 11.3 squared. You can calculate it out later if you want. 11.3 squared minus 8 squared. That's going to end up equal now to pretty, it wasn't exactly 64, but once you take the square root of it, whatever you get there.
Then I got like 7.98 for the other side,
Mm-hmm.
and I just rounded to 8.
So yeah, so what you actually got here is like 63.69. You take the square root of that. Yeah, you get like 7.98. You can round that. That's fine. It's an easy number. You can round it straight to 8 if you want there. Every number there, it technically goes to 1 decimal place, but I can see why 8's an easy to work with number. That's okay. So I know that the bridge is 8 feet. This little triangle here is 8 feet long. Okay. Yeah, and I know there's 6 of those around, so it's just 8 times 6. So how long is the bridge? It is 46 feet long. 48, thank you. 48 feet long. And that's it. On a game.
40 years or 46 years?
Math.
I
Mhm.
couldn't calculate the interior angle.
The interior angle. So yeah, you can that one uses trig. Yeah, so like if you remember it, cool. If you don't, that's okay. We'll revisit that in 2 weeks. Yeah, so you can just skip past it for now if you want. That's fine. So we don't really need the trig stuff right now. There's not a lot of those types of questions in there. So so we could probably don't get up and go just yet. Just listen to me for 30 seconds. So we're 5 minutes from break. We may as well just go for break now, come back like 5 minutes early instead. And then what's going to happen is when you guys get back is it's just time to continue working through this. Now, if you look at question 9, that looks like a really similar question to yesterday to give a shot. But so we're going to go for break now. When you come back, you can just finish up working on the book. Let me know if you want any help, of course, but yeah, doing good so far today.